All right, thank you all for coming during the lunchtime. Um, so it's not going to be like a boring history lesson. First time I'm doing this presentation. Last year I presented about the IBM 5100, but I'm old enough to kind of remember the world before there was a computer in every home. Like I said, there's a lot on YouTube on the history of computing, so I'm going to speed through the first part of this. And no disrespect to that history, but a lot of it's been covered. I have some interesting aspects that I think are more recent or focusing more on the 70s. So I am going to go fast through the first part. I'm not going to go all the way back really to the 1600s. There's going to be a couple highlights that I'm going to touch on. Um, there's some interesting aspects before electronic computing that I think are important to talk about, but about 10 minutes, so I'm watching that clock up here to keep me on schedule. But the bulk of it will be the second part. I have some posters out in the exhibit hall, and that's at intermission. I'll touch on a couple aspects of those. All right. Not a history lesson. So to keep me on schedule, my ground rule is I'd love to talk about everything on here, but my ground rule is I can only talk about what's in the red box, to keep me on schedule. So, in the 1770s, the writer, it still exists. You can go see it in a museum over in Europe. And an example of, an automaton, there's several of these, in the world, about a dozen, I think, still working from that era. But it's that idea of it was programmable. You change the cogs on the back of it and it would change what he would write. Fascinating technology, at the time. There's no electronics, obviously, in 1770. It's all mechanical. During COVID, I found an upright piano and I restored it. And so I was reading about the history of, upright pianos and how those came to be. And, there's 150 years of history there. But again, focusing on the red box, the epitome of, upright pianos was the player pianos around, the 1900s moving on. There were a few before 1900, the late 1800s. But it's another example of a programmable device, right? You've got this concept of punch holes that specify what notes to play. Yeah, we got the mouse cursor also. Okay. And then on the left side, it's got more controls where on some of the more advanced ones, you could change the tone and speed. Here on the right side, it has the words of the music, so you could sing along with the song. I've seen some fancier player pianos where they've got two scrolls, and it would make a copy of what it was playing in real time. But that copying brings up this aspect of, it's intellectual property. People took their time to create those songs, right? Now people are just copying them through scrolls. So that was a discussion right around the 1900s. Congress was involved. And Warner Chappell, they still exist today. The guys who copyrighted Happy Birthday, right? That's changed recently, I think. But it was a big deal back then. All right. So speeding up now in the 1940s, and again, no disrespect to the history of all this. There is a computerhistory.org. They have a timeline website that kind of goes in depth about each of these. But again, focusing on the red box, the Manchester baby in the late 1940s. Couple of cool things. It had a stored memory. But here, it's got a CRT screen. Now, it doesn't have a character generator, so it doesn't see, ASCII like we would see it. The yellow is how many of them, or at least by my best reading about how many of these were made, right? There was only one ENIAC, one of these Mark Ones. But the Manchester baby has been, I don't know if restored's the right word, but there's a replica of one over also in the UK. So they demo one of those in one of the history museums over there. But that idea of having a screen that you interact with, I think was novel there in the late 1940s. So advancing into the 50s, where we're transitioning from vacuum tubes, more in transistors. The first transistor radio was an excellent kind of example. Instead of those large jukebox kind of things in your room, you can now have a portable transistor radio. Those TR1s are really expensive now if anyone has one and finds one. So the LGP30 was one of the early computers, and it had a big case. It didn't really look like that when you walked up to it. It had a big cabinet and looked nicer. But again, the arrow that I'm pointing at here, they called it an oscilloscope, but it was a little digital screen. It showed the state of the registers. It had little lights that would come on, even there in the mid 50s. Great machine. I was reading through its manual. I mean, it was a real computer, and they made about 500 of them. But one of the problems, I guess, with the large-scale computers of that time with using vacuum tubes is you spent more time replacing all those vacuum tubes than actually using the computer. And so they needed a better solution, and that motivated, and of course the war also, World War II. motivated better computers coming along, and the transistors were in the early 50s. You had kind of some hybrids. They were like half vacuum tubes, half transistor computers. Um, Violating the rule, going outside the red box. I do want to mention plug boards before assembly programming. This is how you would program the early computers in the late 40s. If you think programming was hard now or annoying for whatever reason, I mean, imagine this spaghetti mess of wires. Ken Sharif, a lot of people might recognize his name. He does excellent blogs online. He kind of reverse engineered one of these plug boards, kind of wire by wire, and kind of determined what it did and found it was some kind of accounting program. Back in the day, so he has a picture on his blog. There's like a rack of these plug boards. So to load your software, you pick the plug board that you want to load that day and load it into your machine. All right, moving on. So early first half of the 60s, a lot more computers are being used, and their banks are starting to use them to verify checks. CAM machines and CNC machines are starting to use computers in the early 60s. They found more uses of computers besides just doing like census and insurance records. IBM obviously dominated the world, and then there was like everyone else, a small percentage market-wise. But the story here is this young lady, Mary Wilkes. I think she's still around. So the picture here is, it's a real picture, kind of the first example of a computer used in someone's home, a home computer. The story is, if you're not familiar with it, is that office of digital equipment, they were moving, and she wasn't able to move with them, but they appreciated her work so much, they said, well, we got to move, but if you can't move with us, why don't we just give you a computer that you can work at home? I think around in that year, yeah, mid-1965. And she volunteered to do that. She was great at writing operating system software, and I think she did it on tapes and would mail them to him on the update. So technically, I mean, it's not wrong. It's the first home computer, but it's not what we would think of as a personal home computer. If you really look at the picture, there's like some modules here. There's, I don't know a lot about the Link 8, and we can read and look that up. But one difference, little differences, whatever this component here is not here on this picture. There is some kind of like oscilloscope type screen here. I think these might be like tape data drives to load and save. So interesting lore there. The UNIVAC machine, just real briefly, great machine. The one quick thing I want to say about the UNIVAC, most computers, they got cheaper over time. The UNIVAC actually, once they realized what they had, it increased in price. The first one, it was like 100,000 or something, and it went up from there after they started selling it for more. It was a trainer type computer, but that was one little factoid that I learned that was interesting, once I realized what they had. All right, we'll move on. So the second half of the 60s, almost everyone's universally familiar with the IBM 360 and the huge success of that system and the PDP 11 and 8 series. I believe, from what I've read, and we'll save questions at the end, I may make mistakes or misspeak, but a lot of the engineers involved in the PDP 8 project, I believe they were also involved in producing the Data General Nova the following year. I haven't been able to find out, Karen. This is a prop photo, right? She's a saleswoman, right? She's not a technical person. She's just asked to deliver this machine, and they said, "Hey, while you're doing it, let's take this photo opportunity to show you've got a portable computer." Thinking her Volkswagen Beetle. The innovative thing on the PDP, I think it was like 18,000 or so. I mean, it's more than a house still, but it's in that realm of possibility that people could buy this machine. While all that's going along, my side note, up here, again, Ken Sharif at his blog, he dug up, Fairchild was, the precursor to microprocessor. They developed an ultraviolet lithography technology. They started in '59 when they kind of figured out there's some merit to this. And it took them, another decade to mature that. But Ken, he's dug up in 1962, a military aircraft. I'm not too familiar with it, and I don't want to steal his thunder. Check out his website. In the last few years, we've talked about the F-14, the fighter jet. It had an early version of a microprocessor, and this might even predate that. And the next slide, I think. All right, so this difference on those two kind of branches of technology. So IBM heavily invested in this solid logic technology, and I found this manual that had this nice picture that shows mid-60s it was this, and then it just got denser components over time in the early 70s. And they just call it a monolithic solid state technology. And if you tear open one of their RAM chips or their version of a RAM chip, it's the real deal. That's what it looks like inside. This is the only picture I found of how their manufacturing process. this guy, he's got tweezers and he's not like putting the components on there. He's just showing for scale. This kind of spaghetti tube thing is putting the components on there. Imagine it's getting hot and welding them effectively on there. That's pretty fancy, but maybe not the most efficient. Or what Fairchild is doing. So over in Palo Alto, at the original ground zero of where that technology was developed, there's two plaques. One from the state of California and the smaller ones from the IEEE organization. And it's still over there. You can even Google Drive it if you want. You'll see the plaques there. Where they were figuring out, I mean, it's amazing technology and all that's described on the web also. But basically you work it in large and then they miniaturize it, right? And, it's night and day difference. Like you can make a few of these a day, or you can make, thousands of chips a second, the scale of it. When you want to build a computer. So IBM was good. They sold a lot of computers, but it was in the order of, 5,000, 10,000 kind of thing. If you need to scale that to millions, to the masses, you need a different technology, and this was the way they did it. Sorry, I got to speed through the first part because the second half will be lots to go through. So, Datamation was a magazine for several decades, great magazine, and I'm thankful that they're online now. And I was reading through them. So in 1968, these weren't leased computers. You could buy a computer for about $30,000, and it's effectively a personal computer. Yes, it's large, but they're all 16-bit machines, options of 4K and 8K. They could have their version of serial port and modems. This one's boasting that it could run Fortran, this DDP. Now, I haven't seen these machines physically to verify, that they existed and were sold, other than the magazine articles. I work for Lockheed, so another branch division, Lockheed Electronics in Los Angeles. Funny that they called it a Mac, decades before a Mac ever came around. I don't know what their Mac stood for, though. And the Cell 810B, that had interrupt options. Scaling that to today's money, I mean, yes, that still costs more than a house, relatively speaking, but they weren't leased computers. You could go out and buy these. Not at any store. I mean, you have to call the company and have it ordered, but obviously business class machines. So then, in 1969, I came across these two. In December 1969, a system called the Daedalus. I've never heard that anywhere else other than Datamation. So after the talk, if anyone's familiar with Daedalus and whatever happened to them, and it may be hard to read. They were at Las Vegas. So Las Vegas is still famous for doing, the electronics show in early year. But even in 1969, they had some component of computer shows there. And they would say, hey, if you missed us in the crowd in Las Vegas last month, here's more information. This is a year later. So 1968, we're talking $30,000. 1969, they're advertising $11,000. So you see how quickly prices are coming down. It's not super impressive on the Daedalus. It's basically a typewriter, but it is a programmable data terminal. They don't call them, personal computers. The first term was programmable data terminal. It talks about number of instructions. I've seen a picture of one of these open. It had like 14 cards in it. Now, the Viatron is interesting for a couple of reasons. That it has this tape, the VIA tape, that idea, before 1970 even, that you could save your data on tape. The problem with the Viatron, it's a little bit of a sad story. And two engineers, they gambled that the technology was going to mature, that microprocessors were going to come sooner, and they gambled that they're going to be able to sell lots of these. Unfortunately, they didn't quite time it right, and they ended up getting fired because they didn't meet their, what they said they were going to do. And so obviously Viatron, they went under. But it had a color screen, 16K, a 16-bit machine for $10,000. And somebody's restored one of these. So this one I've confirmed it existed. There was a website. It had 14 boards. I don't know if they got it runnable yet, but it's been confirmed that it did exist. I think around 2017. Someone found a physical one. I'm going to skip this one. It looks like a TRS-80. It has a light pin. I don't know much about computer communications, but the thing is, the real computer is under the desk. So it's not like inside the keyboard kind of thing, like a TRS-80. It did have a character generator, and that was another bulky machine that they had to keep under the desk. Okay, so a little bit of an intermission here. So I like storytelling. I played Ultima 9 when it came out. I was one of those suckers. And the game had a lot of flaws for other reasons, but one redeeming kind of aspect of the game is it had this tapestry of ages that you could find in the game. And you click these crystals down here, and it had a voiceover that would tell you about the history of the Ultima world. And so that idea, I like wall morals. I like telling the story through pictures and then having people talk about those pictures. My wife and I had the opportunity to go to the Vatican museums, and I guess this year is the 500th anniversary of the Gallery of Tapestries. Same idea, I mean, using woven pictures, right, to tell a story. And so my daughter and I were talking about that, like, why don't we make a mural about computer history? So, imagine 500 years from now, somebody can look at that. The world can be destroyed several times over by then, but maybe there's this mural that tells the history that still exists somewhere, at least in pictures. And so we looked around if anyone had done something like that already, and we came across this. We came, Robert Weiss, I hope I'm pronouncing that correctly. He's not in China. He is in Switzerland. CH apparently means Switzerland, if most people aren't aware of that. The abbreviation, Confederation Helvetica. So the poster is in German. If you've seen it out in the hall, you've seen a couple versions of it, but he started in 97, the 20th year anniversary, and he's made about every 10 years, he's made updates to it. So I'll peek ahead. This was his version of it, and my daughter and I, we liked it. It's very informative, right? But it's a little too informative. It's not that idea of a moral of something that you would just nicely, yeah, you could make a poster size and walk by it and read it, but just to quickly kind of tell that history of computing, it wasn't quite what we were looking for, but I do respect it for what it is, and how he's lined out, obviously, the years, the major software packages, and that he included, like, Time Magazine, major events going on in the world at that time. And I also like this graph that he has in behind kind of the inflection point of when computing capability really took off. So I don't know what the color scheme means, other than just major divisions of sections. You got to pick some color. So my daughter and I reflected on that, and kind of we grouped computers as kind of, titans were the big iron. I don't know if there's a standard definition of big iron. Big iron might apply to equally equipment in the 50s, but it's obviously things with big iron rails. The IBM 704 was referred to as the hulking giant, but like I was telling my daughter a couple of years ago when she was younger, there were a few giant titans in the world, and then there were large giant animals in the world, and then it progressed smaller and smaller, and then we domesticated the animals. And so that we thought that was funny. Okay, we've domesticated the computer. We brought it into our homes. They're no longer like hulking giants walking around in the world, lumbering around headless, for lack of a better word. You look at it like you were literally walking inside the computer. Now you're walking around the computer, and now you're kind of congregating a group of people. Even children are touching the computer by the 70s. That term, I didn't come up with appliance computer. I'll show who came up with that in a moment. More formally, they split the computer progress over the last century, really, into these generations. First generation being the vacuum tube, second being more the transistors. There is a kind of intermediate third generation going into integrated circuits. The fourth generation is just more of that, a more extreme version of the integrated circuits. If you're not familiar with Douglas Engelbart, shame on you, very famous person, who kind of pioneered that idea of using a mouse and kind of thing early on in '68. He did The Mother of All Demos is on YouTube. You should look that up if you're not familiar with it. I believe he used the CDC machine here at the desk, but this is a mouse. It's a little hard to see in the photograph there. But he's got that thinking of a wedge-shaped computer, right? You got a mouse. I don't know what the other device, he had a left-handed side that he didn't call the mouse, but it was another type of push-button input. He still got the round screen, right, but they're still working on that. Then I haven't formally seen like later generation, fifth generation, sixth generation, and so on. But after 1984, nowadays we have FPGA and ASICs. The hardware guys can talk about the technical differences of that. But nowadays we do, if you're not aware, you can rent time on quantum computers. Quantum computers run at near absolute zero, so they're expensive to actually run. That's why you can only lease time. To me, I think it's come full circle that now we're leasing time on great computers again. I think that's interesting. What the next 60 years is going to come about from that. We'll see. I think it'll be a while before we have absolute zero things on our desk at home, but we'll see what happens in the next 60 years. So this is the poster my daughter and I came up with. We compromised. Like somebody said, well, you should include the price and more information. I said, no, I'll just stick with the names. I don't want it too wordy. I just want a picture that you can kind of relax and read. So we have the years and the major processors. So my daughter did the background and the arrangement. My real contribution, it's faint. There's little gray highlights in here that represent silicon sand. The story of data, paper tape, fan tape, that progression up at the top. Now, this isn't a complete poster. Obviously, there's like 10 times as many of these computers in the world. Our idea was we would make 5 of these and we could match them together like a puzzle to tell kind of the history from the 30s, 40s moving on forward. Kind of in about 15-year groups is what we were thinking. So this is our first. It's freely available. I did it on the Creative Commons on GitHub if anyone's interested in any copy for whatever purpose. We have a little YouTube video. A couple friends of mine did the voiceover of it. People listen to different styles of music, right? So I had 2 friends, a male and a female, just to get those different frequencies. People just might like it in different ways. But they're both our videos that we put together. And people might like the different styles and how they do the voiceover. And they go into kind of more detail about each of the systems. The other highlight, the takeaway, the Z80 systems along the top, the 6502s along the middle, and kind of the Intel systems along the bottom. All right. So part 2, I think we're doing good on time. So this book I came across was written in 1968, and if those look like paper clips, they are paper clips. It talked about, I would call it first principles of how to build a computer. Like if you go back to Charles Babbage, right, they're building computers out of brass and mechanical components, and you can still do that. You can build a computer. You don't really need a transistor to build that idea of a computer. This book, I've been reading through it. It's on archive.org, a PDF. It's a pretty easy read. The funny thing about it, if you know Quaker Oats, they got that round box, how they sell it. This book talks about making drum memory using one of those. So I would love to see somebody tear through this book and build one of those. We'll see in one of these VCFs if someone gets time to do that. It is a pure computer. It's not going to have like a keyboard monitor kind of thing. It's not going to have VGA out, But it'll compute. It has an ALU. It'll add 2 numbers kind of thing. If you know Usagi Electronics, right? He did the vacuum tube computer. Very respectable work on what he's done. But the main point is that thinking that book was available, and just imagine the thinking that it did, like the young people, that generation in the 70s, they read this like, yeah, I could build a computer. Then by the end of the 70s, you have this where, like I was saying, the ultraviolet lithography, where you're building a computer large and then they literally miniaturize it in almost like microfilm, how they make processors. And so you're using computers to make computers by the end of the 70s. Okay, so officially, the first computer, the first personal computer, it was declared in 1986. That museum has moved. It is now the Computer History Museum in Mountain View, California. They declared the Kinback 1 as the first personal computer. And nowadays, some people have different reactions to that. Mr. Kinback, John, is still with us. He's probably in his 80s. He only made about 50 of these, and they were about $700. So he meant them for schools. He didn't really meant them. There's no microprocessor in it. It had like 256 bytes of memory. That panel, right, I believe one of them was Steve Wozniak himself, was one of the panelists, and somebody from Byte magazine, and I forget who the third person was. So it wasn't, people who didn't know anything. It was sincere people kind of making this determination. So you read a little bit further, then they said on that same day, they declared 1973 the Micro N is the first computer, personal computer with a microprocessor. I added the little Intel Inside sticker, because it does have an Intel 8080 in there. He is not so he was like, T. Trung. He was a French citizen, came from Vietnam. He grew up in France and was educated there. He was more the business and kind of leadership of it. He ruffled feathers with some, trying to take a little more technical credit than maybe he should have. Francis, I believe, was the actual technical person putting it together. So a little wrinkle there. Lee Feldstein, I'll go over some of his contributions. Yeah, he did the Osborne and Sol 20. So he was there during this kind of announcement in 1986. As I mentioned, in the 90s, that they relocated from Boston clear across the country over into California. All right. Over in Japan, the birthplace of the personal computer, they have a plaque on the 7th floor in Akihabara Station. NEC is still around, making electronics, and they declare, now they do, when you translate the second part, they do say the personal computers in Japan are born at NEC in 1976. Now the plaque, I've last seen it in 2008. We have some friends going next month and we'll verify to see if the plaque is still there. TK, it does mean training kit, so it was a, I don't know if they cloned, it wasn't literally a Z80, but it was a Z80-like processor is my understanding. So anyway, that's how they honor that history, that building, that floor, and all that work still exists. Down in San Antonio, they didn't use the word first in here. They're just honoring the fact that there was a lot of technical work done in the data point and around the year 1970, 1971. But they don't use the word first in here, so they're not making that claim. But it is a desktop personal computer. It started in 1969, and it was a pretty decent computer. It was still expensive. They had trouble competing with IBM. Not so much, they had a good product. The competition was, how do you advertise this thing? Like if you advertise a computer, nobody's going to know what it is, right? Or what to do with it. So the trouble in early 1970, nobody knew how to market a personal computer. There was no software. Nobody would know what to do with it. So my analogy is like buying a car before there's any roads, right? It's going to be pretty bumpy. But the excellent thing that they really did is they made an 80-column screen, and it's a fantastic quality screen that they did. And there's a lot of other how they contributed to Intel and kind of nudged Intel to make the 8088. All right. So those are plaques that are out in the world. Let me back up. This plaque from IEEE was declared in a couple years ago now, 2022. I haven't seen the plaque yet. I imagine it's in one of the museums down there to physically see it. I don't know if Region 5 is San Antonio. So all that said, then the Italians come and they say, well, hold up, what about this thing called the Programma 101 in 1965? And that's the price then. If you inflate it, today's price is 10 times $30,000. So it costs more than a car, relatively speaking. But the key thing is, most of us will agree the Intel 404 was intended for a calculator kind of machine. It's not a programmable machine. This is what BuzzyCom asked Intel to build them for. Going back into the 1800s, they had an idea of, it's hard to see in the picture, but there's little rollers here that show numbers. So as you're adding up, you don't really need the printer. You can see the results on the rollers up here. So neat mechanical machine. Cool thing. All right. So the Olivetti Programma, it was a programmable machine. You could insert a little card in here, and I haven't read the manual on this thing, but I presume one of the things like the factorial function, right? You don't want to type in the factorial of some large number, so you could probably slide a little card in there, punch in a number, and it would, as an example of a little program that you could slide in there. It didn't have like 4K of RAM. I forget how much it had, but they are right in that it was a programmable device. HP a few years later made the HP 91A. So I dug up, or the story here is Olivetti actually ended up suing HP for copyright. I don't know exactly how that worked back then across international boundaries, right? They sued and they actually won, and it was a significant amount. Obviously it didn't end HP, but I'm even in 1960s dollars, I think it was like $3 million for the lawsuit. Obviously you see a lot of similarities between the machines, so I mean they're not wrong, but I don't know all the details of the lawsuit, but that happened in the history. HP probably doesn't talk about that a whole lot. I mean, they probably made certain innovations. The little slot on the HP is here. There's a little programmable card thing that you can put in there. Now, is it the first personal computer? I mean, it's not a full-size keyboard kind of thing. People just have different opinions of that. So this is when you talk about an engineering product, what's the first of anything, right? You talk to the car people and they say, well, let me tell you about the 1880 Benz, right? That's obviously the first car. Well, what they're called changes over time. It was first a horseless carriage. Like when they're making this, they're borrowing wheels off carriages of the time. Funny thing about these early carriage things, I believe they were electric. So it's funny that the first cars were electric, and we're coming back to that. So the Model T, I looked at that. Is that the first car? It's rough. You got to break your arm to start it with this crankshaft. I always thought this was a spit can, and it's not actually on the side of the car. It holds a gas to light up these lanterns here. It's some kind of kerosene thing that lights up. So you're interior dome lights are these things. It does have headlights that run off the battery, but they're weak. But if you want to get out of your car during the dark, so they had this canister on the side. So cars were hard to start by 1910. The Model T, you don't just hop in it and just go for a ride. No power steering, all that kind of stuff. So it was rough. Is it the first car? When you go to the Model A 20 years later, it's looking more like what you would hop in it and just start driving this thing. You don't have to crank start it. The maintenance is probably different. So it's subjective on what you call the first car, right? Just like the first computer. Or the first, really anything. First airplane, etc. There's an excellent book about the data point, so I'm not going to talk too much about it. The one thing I wanted to highlight is the original data points. If you're collecting them and you want to get, an original authentic data point, their logo changed. This was their original logo, so you look for the left pointing arrow, and then you tell that's old equipment. That's original. They changed their logo a couple years later to the right pointing arrow, stylistically. You stick in the nitpick I have is it a personal computer? It doesn't run on its own. It doesn't. I think within the first year they added some ROM, but you had to have the tapes. You put in the tapes and it would load off one of these tapes. And so then my question is, well, who initialized the tape? Like, where did that come from, right? Could you use another data point to initialize that? Well, no, it was kind of dependent on some form of mainframe. They called out which machine that they used. I forget exactly what it was to initialize those tapes that they sold with that had the boot up ROM. Like I said, within a year or two, they solved that. They actually did have a proper ROM and you didn't really need these tapes anymore. Okay. So going through 1970s, I'll kind of go year by year, kind of major highlights. We talked about the Kinback briefly. That's how many sold on the West Coast. Intel's funny. They make this fabulous technology, and it's like, here's this chip. You guys go figure out what to do with it. They tell the world. They didn't get into the PC. They didn't start making computers themselves, and it was kind of a wise decision, right? Intel's still around. There's like, whatever you want to do with this chip. The computer industry has been fierce, right? There's been a lot of losers and businesses that have failed, fighting for the computer industry. But Intel, here's a chip, here's an example of how to use it. They charged a lot for the Intellect. It was like $7,000. I mean, a lot then to get a developer kit. But it's an example reference system on how to use their equipment. And they write, I think there was a Fortran compiler also. I've been to the museum in Washington, and they have two of these. They have the 4004 version and the 8008. So John Draper, John Draper didn't pioneer the idea of the phone phreaking. There were several decades. There's been kind of some new information recently. It doesn't change the narrative or the story of that. John Draper, I mean, there was a lot of drama with him. He got arrested and things like that. But if you forget what frequency is, I just think of the Atari 2600. That is a coincidence. That frequency, if you don't know, this toy was in the Captain Crunch, and you could get out, and it happened when you blew the whistle. It happened to be that frequency that would trigger, you get free phone calls, free long distance calls on the phones. It's a 26 hertz tone out of that whistle. Now I'm simplifying the story. There's some more aspects to it. And I always thought, is that why they called it the Atari 20? Was it like an inside joke? I think no, because first of all, when the Atari 26 first came out, it wasn't called the 2600. I think it was called the VCS, I think, in 19, and they changed that name later to one of its internal parts, was labeled a 2600. And Steve Wozniak, he partnered up with Bill Fernandez, and they made this cream soda computer. That happened in 72. I haven't found any specs on what they actually used or what it could really do, but, they're young, late high school kids building computers at that age. Maybe they were inspired. Wozniak's father was a Lockheed engineer, so he probably was inspired by aspects of that. If not inspired, maybe funded by good old dad. All right, 1973. So we have one of these out in the exhibit hall as an example of an early, before the Altair, before anything in the 80s. It boots up to BASIC. It's not Microsoft BASIC. HP, BASIC started in the mid 60s where it was maturing on the mainframes, but HP incorporated it in their. They sold it as a calculator. They didn't try and call it a personal computer, but it's got a full keyboard. That Model 9100, it was hard to program. Like if you just want to do a matrix multiply and addition, you have to key in a lot of complicated things to remember. This isn't the equivalent program, but it's easier to understand BASIC as we would mostly the big difference if you type print, it'll literally go to the printer. If you type display, it goes to this one-line LCD display. These were expensive machines. Canada made this MCM70 that came in and had APL, but it was an attainable computer. It's an example of that idea of something you could buy and boots up the BASIC and you could start using it. But it's not quite there as far as what we would use in our homes as a day-to-day driver of a computer. In the same year, the Alto was introduced. Fantastic machine, well documented online. And IBM was inspired in part by the HP 98, so they were a couple years behind the game. This is their prototype, and I talked more about it last year. And they matured it into the IBM 5100 a couple years later, so it was their equivalent of it. One difference, it didn't have a one-line screen, right? It had an actual CRT, a multi-line CRT in there, and you can attach an external monitor to it also. All right, so a lot of things happened in 1974, 73, 74. They realized what was coming. The microprocessors were getting better understood from Intel. So I have like 4 or 5 slides on things that happened in 74. The micro N that I mentioned earlier, we here in the US aren't really familiar with it. It was a French product. When you bought it, this isn't what it came with, right? When you bought your 1750, it just had this one box. You had to find your own input device, and CRTs came later. But I was just reading the manual about this thing, and it's very thorough. I mean, it could be used as a machine, but a computing machine at home. But the designers of that, and I can't remember their names, they were interviewed, and they didn't really intend it as a home computer. They said it was really intended for toll booths, right, to manage those. These 8008s, it can only address up to 16 kilobytes. I mean, you can probably do virtual memory like any other system, but the address space is limited, the capability is limited. I read somewhere that 90,000 of them were sold, and I'm suspect about that. I don't know how to verify that, and I question that only because these are really hard to find. Like, I think there's less than 10 that are known in the world. So if there were that many, I think there might be more known about it, but it could just be, I'm not in France day to day, and maybe they have more of them over there than I realize. Another thing in 74, so at the University of Illinois, they made a version of BASIC for the 8008. Not a lot of people are aware of that. So when I say they made a version of BASIC, it was a concept. It wasn't fully developed. They only had 1 semester to do it. It was their semester project. And so they were showing that proof of concept that a microprocessor, they were ready to boot up and run BASIC. You didn't really need... So if that story sounds familiar, yeah, it's the Bill Gates story a year later. He used borrowed time on a mainframe, developed his version of BASIC for the MOS 6502. So the Selby, famous, famous, I guess is the right word. They didn't sell lots of them, right? They sold a couple hundred of them. But in this QST March magazine 74, right, I looked it up it's a small print, but it's there. They're announcing, it's funny that they call it a mini computer. That's not what we would think of a mini computer today. It's like a Mark 8. It's this series, and there's one out in the exhibit hall. I'm glad he brought it this year. Nate Wadsworth, he hand wrote this letter in 73, kind of, his, storytelling of, this is my thought process of building this computer, that it was time. He partnered up, he names out Bob Finley and a couple other people, that they had this idea to make this into a product. They pooled their resources, and it was like a kit computer for 440. The Intercolor, I don't know if a version of that, I found a brochure where it was advertised in 74, but I don't know if any of them were actually built. They come back later in the later 70s. But there's some rumor, I don't know if they actually ever built one that used an 8008 or if they waited for the 8080 to become more available. It's an expensive terminal. I think some like factories and industrial shops use these, and I'll have another picture about them in a little bit. So Wang, in 1974, they were advertising for almost $7,000. You can get a boot to BASIC system. It's a great system. I played with the emulator. One of these does exist. It's still runnable. It's at one of the museums in southern Germany. Stuttgart, I think's the name. And the weird thing is, like, this whole box is its CPU. It's another one, they hide the machine under the desk kind of thing. Like here, this is the machine. Well, there's more behind the desk than it appears. It's funny they use that slogan, what you see is what you get. That came back later, in the 90s in a different context. Their context here is like, in the back of the magazine, if you order a computer, it might not show up, or it might not show up exactly, you ordered it. Here they're saying they're legit in that if you see all this, if you order this, this is what you're going to get, is what they're meaning there. But the Wang systems were used in a lot of desktop publishing systems. Great system. I mean, still expensive, still costs more than a car. So business class machine, not really used in the homes. 1974 were these two things coming about, where the idea of you can build your own keyboard, you don't have to use teletypes anymore, and the circuitry for that, and a character generator, and that idea, understanding the electronics behind that. Don Lancaster, huge pioneer. Did he pass away in the last couple of years? Recently, I think. Yeah. Um, Titus in the radio magazine, he published the Mark 8 in 8008, but that was 6 months before the Altair. The Altair was a better kit, in my opinion. Also in 74, so these two kids, they were in Florida at the time, Richard and Scott Adams. If you've heard Scott Adams, he made a lot of adventure games for the TRS-80 Model 2. His brother was more on the hardware side of thing, and they cobbled together their own homebrew. And you see that looks like the TV typewriter. They were inspired by that here on the typewriter that they made. I'm not really sure what the computer is here. It's a lot of cards, but they do show it booted up. So the interesting, they use this 16-bit National Semiconductor machine. I haven't seen a lot of people using that, if that's even still available, but they deemed it a viable option to make a computer out of it. Then what is this? I have one of these out, and I found one of these. It is a tape load store, but it's different. Most tape cassettes, has the push buttons, fast forward, rewind. This one has a dial kind of thing, and so we actually find that, yeah, it was a real thing. They had two of them, and one of them's out in the exhibit hall. So another thing going on around 73, 74, there was this activity, they called it computer memory, in Berkeley, California. And it was the idea of what would people do with a computer? Like, they knew computers were the future, but really what would people do? And so they put them around the community there, and you could walk up and you could, they put them like in laundromats. It's hard to see, but it's a laundromat back there. And it's funny, like intuitively, this young child, like he's touching the computer, which, years later, that's what we do. We have touch computers. We want to interact with it. It was free. You did have to put a coin in, I think, to start it, but then it would just feed your coin back out. I think that keyboard looks very modern, but I'm not sure. I'm looking at this picture, and it looks like maybe that was the keyboard they used. I'm not sure if this is one of them that still exists, but basically you walk up to it and you could kind of, it's social media. You could like message boards and write a message, and people they write about this. They come back the next day and they get the answer to their message or whatever question that they were asking from somebody they don't know on the cloud, right? Their little network that they put up. I think it was all modems. It wasn't like Ethernet or anything like that. So fascinating kind of experiment that they did over a couple years that a lot of people might not remember, that it was kind of lessons learned on, yeah, people are interested and they're not really afraid to use a computer. Give them some software to use it with. Okay. Ted Nilsson, I have this book out there. He wrote Computer Lib. And Ted Nilsson, he's still with us. Last I heard, he's between Australia and Japan. He's working on... He started Project Xanadu a long time ago, but there's aspects of it that he's still working on. And it's a different kind of flavor of the web. One of the things like bidirectional links, anytime you link to someone, kind of one of his rules, you should be able to link back. I'm not an expert on Xanadu and the other thoughts that he had, but he had a different kind of vision for how the internet would go. But he saw the computer revolution coming, and it's not a book that you just sit down and just read. And once you get it in your hand, you'll understand. It's kind of all over the place, the narrative that he has. You have to like flip it over to read certain pages. It's an interesting book. So it's a collector's item if you can find one. Interesting read. Okay, so 1975. A lot of us are familiar with the IBM 5100 and the Altair. I don't want to say they were really compete. They were just different orbits on how they existed. But obviously the Altair was a lot of excitement that, yeah, you could get a computer for $400. But was it really $400 to really make it do anything? You actually, okay, if you had a friend who had a teletype, maybe you can save some money there. Otherwise, getting one of those was expensive, right? $1,500. Getting a disk drive or getting it to really do anything. But within months, one of the things it could do, right, it could play Daisy Bell. So that was your killer app, right? Daisy Bell, if you don't know, that's significant because the IBM, it actually sang the song of Daisy Bell in 1961. There's a YouTube video about it. It's not the best recording. It's a little creepy how it sings it. But it is an IBM computer singing that song. And so that's why we just a homage to the Daisy Bell song. Then the HAL 9000, as they're turning it off, I think, hopefully I didn't spoil the movie for anyone. It's singing Daisy Bell, for the IBM, honoring that history there. So the IBM 5100, I'm partial to it. I have one, and been learning a lot more about it. And I found a sales brochure, and people say it was a $20,000 computer. Well, not really. Looking at the sales, and it's probably hard to read up there, but the cheapest one you could get was a little over $6,000. And like, you spend that money, and you could probably run $1 million business for $6,000. You could plop that on your desk. You probably have to buy the printer. But it could do, it was stable enough, right? It came with that CRT. You get 16K of RAM for that price. You could start doing, could run a business with no, figuring out what components I have to put together and flipping switches or anything like that. So time is money kind of thing. You get a nice, reliable computer. Businesses, there was an ITC credit, and I don't know what the percentages were, but you got a tax credit if they bought it. The government was trying to incentivize businesses to figure out what to do with more affordable computers. Okay, 1976, and to me personally, this is what I call the first personal computer, but people have different opinions about it. In that it was a product intended to be sold to people at homes. It was $1,000. It was a Sol 20. You had to get a few accessories, more RAM. The TV had to add on that. But you could get a sound card for it, a multi-voice sound card. You could get a modem for it within a year. And it had like advertised software. It had BASIC that you could get on it. It used the same processor, I believe, the 8080 as the Altair. And it started at S100 bus. So these exist. I've seen at the other VCF in Chicago, Midwest, a couple of these out there. It's a great collector's item. The keyboard's rough. So IBM had great quality keyboards, right? Nobody really questions that. These keyboards, if you don't use them after like 6 months, they got like foam pads and they get really rough. So there's more maintenance. The quality might not be there, and that was the same on the Commodore PET. Similar, not exactly the same. It wasn't foam pads. But if you look down here to get a disk drive, it's expensive. It was $2,000 to add a disk drive to this system. So back to that intercooler that I was talking earlier. What is it? 1978. It had a color screen, and like I said, I think it was used in industrial context. Pressures and showing, those were the ones that could afford it. It was $2,000, but this little asterisk, that's if you order 100 of them. You can get it for $2,000. The unit price is $500 more, so a little gotcha there. It had a light pen, so cool little system. I haven't seen one functional though, so I'm sure there's one around. I'd like to see one of those. I don't know how they're doing the color, how it's doing a color. I think how they had a word. I can't find it here. Started with a C. Convergent system. When you open it up, it's weird how it's different than I think what Apple's doing. So I don't know how they did the color. All right, so I want to talk about the Homebrew Computer Club. So one of the things, kind of archaeology, you can look back and you can see the newsletters they had for these computer clubs. And here's one from February 1977. That photo might not be exactly that one, but one of the newsletters, and I was reading through, they had just interesting articles. They were even, how to circuit up this or something new about, some computer that was coming out. Relevant articles that were interesting even today. But one of the pages, they had this survey, like what kind of computer you got. And half of them are like those 8080 based machines. The Sol was 8080 based. The Poly 88 was also an 8080 based system. So about half of them out of a pool of nearly 200. You start to see the 6502. So I'm going to flip to the next one. The highlights of this. What you don't see, though, is you don't see HP, you don't see Wangs, you don't see IBMs and those kind of things. You kind of see the homegrown computers, and I think that's interesting. And that's probably just affordability. These are college students. Although this guy looks a little older, so he maybe he's one of the professors there. If anyone knows about the Sphere, like the one Sphere that was left on the street, I guess it was there because there's only one here at this showing. I don't know what the Jolt. I haven't heard of the Jolt before, so it's interesting. I haven't heard of these also, the BitSlice and RCA. We can probably look those up. I don't know if this is an AMI board. I'm kind of guessing. Not sure, but there was a lot of them, relatively speaking. But it seemed whatever it was, it seemed to have died out. The AMI company. Again, this is February before the Apple II came out. Those are the highlights, how much memory, so those metrics that they're collecting even back then. So on the poster that my daughter and I put together, we intentionally kind of the middle of that, kind of the crossing point where single board computers were helping to get that threshold where it was easier to make 10,000s, 100,000s of computers. They really needed to streamline that production line. And you had young Vietnamese immigrants helping build these computers. That this was a photograph of building the TRS-80 here, not far in Richardson, in the DFW Metroplex. This is kind of how it started. You train them, put these components here, and they had a solder wave machine, and that's how it started. Just like similar to the Ford Model T, kind of the assembly kind of thing. You do one step, and you can streamline that process. Now, one fault that was on me, I should have included the SCAMP on there probably. So it wasn't just the Apple I first. There were several right around that same time. By and large, the Kim 1 was more popular. It was a third of the price. I don't know exactly how many they sold, but they sold them. It's pretty confirmed that it was around 180 Apple I's that were sold in that ballpark. And that helped fund them, it did contribute to the Apple II, at least financially. The Apple II was a much different configuration, still 6502. But the Kim 1 sold thousands of them, and it sold. They're advertised in early like 1982 PC Magazine. You can still see advertisements of them. So about a 5-year run that they were sold and out there. These were obviously in Japan, and I just don't know as much about them. But they were similar idea of single board computers, and they contributed to that lineage of the PC 88 series. All right, so the term appliance computer, I didn't come up with that. This Carl Helmers came up with that idea. And he says, we as users, or people as users, like, they don't care about the hardware so much, right? They just want to use the computer to do something. Like, we use our phone, we don't really care how it works, right? It just, the software is really where it's at. So he's talking about an appliance computer, just like an appliance you would have that you just walk up, plug it in, and just start using it. It's not, doesn't require an oscilloscope to operate it or an electronics laboratory, right? So that's that. Yes, technically, the first personal computer is back in the 50s, right? But you had to really know what you're doing. You don't just walk up and start using it. So he coined that in this January 1977 of Byte magazine. He was interviewed at DigiBarn in 2009. I think he's still with us. So it's interesting history and perspective that he had. Like, this is a transition time where it's no longer about really the hardware, but what you can do with a computer. And so this is my example of appliances, that have come into our homes over the years. This is an early toaster. It looks scary, but 100 years ago is what a toaster looked like. A hair dryer, iron, an early fan, vacuum cleaner. Microwaves haven't changed too much, right? They're a little more digital dials, I guess. But now you have the computer. It's like, they're so cheap and easy to use, right? Even kids can touch them, right? Mainframes, right? You wouldn't have a lot of kids in the room, right? They'd be breaking those switches all over the place, right? So these are the three, we talk about the Trinity, right? Everyone's familiar with that, the Trinity, the Apple II, the Commodore PET, and TRS-80, kind of that same year approximately that they started as formal products, but they were really the winners of history, right? There was about a dozen other contenders around that time, and I won't go through all of them. But I missed one. There was supposed to be a dozen, but I only had 11 and when I put the video together. So in a moment, I'll reveal what my 12th one was. I think the Saphir was an interesting system. Vector, interesting. The founder was a woman. I can't remember her name, but she kind of gave up when the IBM PC came in 1981. She kind of knew the writing was on the wall to be able to compete with that. So she kind of surrendered and said, well, we're just going to become a software shop and work for IBM, making software in their products. But there's a history here of alternatives. I have a Poly 88, fun little 88 base system. And so the 12th one was really these guys. If you can read that, he's got a t-shirt giving his opinion about the Altair at the time. They're in San Antonio, Southwest Technical Products, I think is what it stands for, SWTP. They were around in 1976. They had some earlier equipment, but they got excited about the 688009 as an 8-bit. They could start. I was reading through its manual, and it's talking about a multitasking. It's like, wouldn't it be nice while you're editing your software that you can flip and do something else? And it's like right there in 1978, they're writing about that idea. And within a year, they start writing that operating system. Starting the origins of OS 9. I believe in one of the talks earlier this weekend was about Nitros 9, so that's sort of the lineage of it. It's still alive and well today. I highlight this tall person here. I think that's Stan. The reason I even came across this is I was doing more research about the IBM 5100, and he was one of the owners. He worked for an engineering company, and he personally owned a 5100 and brought it home and worked on it at night. And his son was wanting a cheaper computer, and he said, I could create a basic. Stan did. And his opinion of the Altair was like, it's a starter kit, right? To really make it do anything, you still have to spend a lot of money. Um, and so their whole concept was, out of the box, useful computers. I don't know the prices that they have if they were affordable. I see them as the precursor kind of to the Tandy movement. But obviously some fun guys to hang out with. So the early days of software, I won't talk too much about this. I'm gearing up to talk about CP/M a little bit. But one thing I've been looking for is there is an advertisement of this 4-voice music board for the PET for $50. I haven't found one, or if anyone knows about it, that'd be cool to see if we could actually find one that still works that you can plug in and do 4-voice out of a PET. This is that Commodore PET. But in the micro world, kind of micro chess was one of the first pieces of software written, like for the Kim 1, I believe, in like 1976. It's funny, Peter Jennings, not the reporter. This Peter Jennings, I think, was from Canada, and he's selling that product, the multiple versions of micro chess for all the major platforms of the day. Flight simulator, technically, Apple. You can give them credit for that. It is a form of a flight simulator. It's not a very good flight simulator, but it does fly around. We'll give them that. Then, of course, the story of IBM, that's well told. IBM's sat back and watched all that activity and said, we got this. They made it a more useful machine and just, their namesake and the quality that they have. That IBM 5100 that I have and I have talked about, right, they used that old SLT technology and they said, well, no, it's time to swap out and modernize and use the modern microprocessors and get on board with that. That's the better way to go. So they finally did pivot and they did that and they well executed a great machine. Nobody knows exactly the secret to it. It wasn't a hit out of the box. It struggled about for that first year. They had to earn their way. But I think it was like a combination of business partners and the whole package. It was a solid package machine that started making it acceptable. But back on the saga of CP/M, right? Even Bill Gates said, "Hey, go talk to this guy. If you need an operating system, this is the guy to talk to." So Bill Gates, he at least tried. But you can read the story about how that got botched. Unix was super expensive back then. Nobody was going to buy, something cost more than the computer. But even PC Magazine was ready to do an article all about CP/M on the IBM. But you can look up that story on what happened. Like the story, he went to fly an airplane during the IBM meeting instead of actually meeting with the IBM representatives. So he literally just kind of botched the discussion. But personally, I think there's more to the story. I do think the 86-DOS was a better product for the time, and that's my personal opinion. But Tim Patterson developed 86-DOS originally. Paul Allen, the partner of Bill Gates, recommended it. He kind of discovered it and said, "Hey, Bill, you need to check this out. This will be a DOS. Keep this in your back pocket." And Bill, I think the story, he bought it for like $50,000. And then also hired Tim Patterson. He was one of the first 10 employees of Microsoft. This is a chart that I've kind of been working on. My main point is people talk about the early, the Trinity as being the first computers, and some people, they don't really even agree with that. They think the first computers were personal computers, personal home computers was up in the 80s. They were like, those are just like almost calculators. They can't really do anything. And I don't know if I really agree with that or not. My father, he ran a small pool business using one of those 32K machines. Like he was able to use it for more than just games. So I do think they were useful machines, even though they had tape drives and were clunky to use. But some people do disagree with that. So they said, no, it was when the mini computers and the microcomputer kind of merged when the 386 came about. In 1986. I don't know if it was really that late. They were like, anything with a tape drive was unacceptable to them. Some people just have that opinion, where multimedia started taking off. I looked up, microcomputers were used in medical, one of the MRI machines. I don't want to say a 6800 or I forget which processor it was using, but early on, right, computers were useful, like for census and code breaking, those kinds of things. And then insurance companies, managing your subscriptions, who has my magazine, and mailing them out and printing all that, managing car rentals, NASA obviously using that. IMP is like the early version of the router. If you haven't read about that, MIT pioneering that, they call it the IMP. The concept of a B tree. So real quick on the B tree, most people think it means binary tree. It might. The people that developed it happen to work for Boeing, and so they might say it means a Boeing tree, or a balanced tree or binary tree. But that idea in computer science was early 70s. So anyway, on this chart, it's kind of the green was why we would use a computer. Blue is some of the major kind of initial software, kind of chess, and then we made BASIC, and then we played Star Trek. C and Pascal were early 70s. Zork was in the late 70s. So the interesting on Zork, it's just a text game, but it needs way more than 64K to run it. So how does that work? It uses compression, all the descriptions. It's clever form of compression on all the descriptions of each room that you're in. And it needs a lot of memory because it needs to remember the game state of earlier rooms that you're in. So it's a fancier program than maybe some people realize. It took a mainframe to actually run it when it first came out. Then the history of like computer games. There's the early version of tic-tac-toe. Tennis for Two, but that interest, that evolution at the National Game Museum, they talk more about the history of gaming. But another users of computer were the audio people, the synthesizers. There was this thing called the Novacord way back. I don't know too much that other than it existed. But then these guys, the Doors, the Birds, the Monkeys, they were pioneers in synthetic music, right? Using computers to make digital audio. So that concept of that opinion, right, was it when these two aspects merged? Still working on that chart and fleshing that out. Where are we at? We've got a few minutes. All right. Just two real quick. It didn't start in 1981 or 75. Link 8, we talked briefly. The Selby. And these are some of the Japanese computers. There's some weird ones that didn't quite make it. This MSA, look, he's got two keypads. Right? What do you do with that? They went out of business within a year. This System B, I haven't seen one. I have the brochure out there. I've seen it advertised. But if anyone actually has a System B, I'd love to see one of that. This NCR, it's a funny name. It's National Cash Register. I think is actually the name of the company. They tried to get in. They were just a little late, maybe. But that's the talk. Appreciate it. All right.